Welcome to JCAG-LAB. This project focuses on the physical infrastructure of the JCAG-LAB network. Before this project, the network was already operational. The Cisco router, switch, server, and other equipment were fully functional. However, the infrastructure was deployed on a desktop-style setup with limited physical organization and cable management. The goal of this project was to transform that existing deployment into a structured, rack-based infrastructure. This project also provides hands-on exposure to the physical side of networking, including rack measurements, equipment installation, structured cabling, cable termination, cable management, and the tools used during the installation process. Rather than simply placing equipment into a rack, the objective was to understand how physical infrastructure is planned, installed, connected, organized, and maintained. This was the original physical layout of the JCAG-LAB. The network was functional, but the devices were positioned on a desktop-style shelving arrangement. The switch and router were connected directly to the network devices, while power and network cables were routed around the equipment. This type of setup is suitable for building and testing a network, but it becomes more difficult to maintain as the infrastructure grows. There was also limited separation between permanent network cabling, patch cables, and power connections. The rack installation provided an opportunity to improve the physical organization while keeping the existing network infrastructure operational. The first step was determining how the existing equipment could be accommodated within a 12U rack. Rack equipment is measured in rack units, where one rack unit is 1.75 inches in height. Understanding this measurement is important when determining how equipment will fit within a rack and how much space should be reserved for future expansion. The rack layout was planned around the equipment already being used in the network. The patch panel was positioned at the top of the rack, followed by cable management and the network switch. The router was positioned below the switch. The PDU was positioned toward the bottom of the rack to provide centralized power distribution. This planning process provided practical exposure to rack measurements, equipment placement, available rack space, and the physical requirements of different types of equipment. A rack shelf was used to accommodate the Inspiron server and additional equipment that were not designed to be installed directly into the rack rails. Before beginning the installation, the required infrastructure components, cabling materials, and tools were prepared. The rack components included a 12U open frame rack, a patch panel, a cable manager, a rack shelf, rack mounting hardware, and a power distribution unit, or PDU. These components provide the foundation for organizing the network equipment, managing connections, and supporting future expansion. The structured cabling materials included Cat6 bulk cable, RJ45 connectors, patch cables, cable labels, and cable management accessories such as Velcro and cable ties. The permanent Cat6 cabling provides the physical connection between network endpoints and the patch panel. Shorter patch cables are then used to connect the patch panel to the switching infrastructure. Several tools were also required during the installation process. These included a cable jacket stripper, cable crimper, punch-down tool, and cable tester. Each tool serves a specific purpose during cable preparation, termination, and verification. Preparing these components in advance also provided practical exposure to the materials and tools required for a physical network infrastructure deployment. After planning the layout and preparing the required components, the rack installation process began. The patch panel was installed at the top of the rack. Below it, the cable manager provides a dedicated path for organizing patch cables. The Cisco Catalyst switch was then installed below the cable management section. The Cisco ISR 1941 router was positioned below the switch. Finally, the PDU was installed to provide centralized power distribution. One practical consideration was that not every piece of network infrastructure is designed to be mounted directly into rack rails. Some equipment requires a shelf or another mounting solution such as the Dell Inspiron and 2 hard disk drives functioning as the network server. This means rack planning has to account for both rack-mounted and non-rack mounted hardware. With the components and devices positioned, the next step was to work on the structured cabling. One of the hands-on parts of the project was terminating the Cat6 cable. The cable jacket was first removed to expose the individual conductors. The conductors were then arranged according to the T568B wiring standard before being inserted into an RJ45 connector. The connector was then crimped onto the cable. This provided practical exposure to the physical process of preparing and terminating twisted pair Ethernet cable. The other end of the permanent cable was terminated directly onto the patch panel. The individual conductors were positioned according to the color coding printed on the patch panel. A punch-down tool was then used to secure each conductor into its corresponding termination point. This created the permanent connection between the cable and the patch panel. Working with the cable also provided practical exposure to how different cables behave during installation and management. Cable flexibility, stiffness, bend radius, and cable memory all affect how a cable can be routed and organized. A cable that is flexible enough to route easily can still develop unwanted bends or loops if it is not managed correctly. Hands-on installation provides a better understanding of these physical characteristics than working with cables only in a diagram or simulation. The objective was to route the cables cleanly while avoiding unnecessary bends and maintaining an organized path through the rack. Velcro and plastic cable ties were used where appropriate to secure and organize the permanent cabling without placing excessive pressure on the cables. The permanent Cat6 cabling is kept separate from the shorter patch cables used at the front of the rack. The patch cables are color-coded to make their purpose easier to identify. This provides a quick visual reference when looking at the patch panel and switch connections. Cable labels were also added to identify individual connections. After termination and cable management, the cabling can be checked using a cable tester. Cable testing helps verify that the conductors are properly terminated and that the expected wiring sequence is present. This provides an additional verification step before relying on the physical connection as part of the network infrastructure. The combination of correct termination, testing, labeling, and cable management creates a more maintainable physical installation. After completing the installation, the rack was inspected from the front, rear, and side. From the front, the rack provides a clear view of the patch panel, cable management, switch, router, server, and PDU. From the rear, the permanent Cat6 cabling and cable management work are visible. The side view shows how the rack shelf accommodates the server and additional equipment while maintaining access to the surrounding infrastructure. The final result is a more structured physical deployment of the same network infrastructure that was previously operating outside of the rack. This project provided practical exposure to several areas of physical network infrastructure. The installation covered rack unit measurements, equipment placement, and the installation of both rack-mounted and non-rack mounted equipment. The project also included Cat6 structured cabling, T568B termination, patch panel punch-down termination, cable labeling, color coding, and cable management. Hands-on use of cable termination, testing, and rack installation tools was also an important part of the process. Another important aspect was understanding how different cables behave during routing and management, including flexibility, stiffness, bend radius, and cable memory. The network itself was already operational before this project. The purpose of the rack installation was to improve the physical organization of the existing infrastructure while providing practical exposure to the physical layer of networking. This project represents another step in expanding the JCAG-LAB network from a network configuration environment into a more complete infrastructure platform. Thanks for watching. I'll see you in the next project.